All right, welcome to section 1.2, points, lines, and planes. Again, this is another vocabulary heavy section. Okay. So let's begin. We're going to start off with a review. This is from the previous section. So we're going to draw a line from each net in column A to its three-dimensional figure that represents in column B. So in column A, number 1, which net does it match in column B? Well, this one looks like it's to be a square in the bottom, and when I fold the tops up, we are going to get a pyramid. So which one of these is a pyramid? It looks to be that one. All right, so this one, when I fold the circles up and I roll it, it looks like I get a cylinder. Here, when I roll all the rectangles together, it looks like I get a box, and there we go. All right, so some new vocabulary here. What is a conjecture? So a conjecture is a guess or a prediction. A conjecture is a conclusion that's reached by using inductive reasoning. And that's actually really big in this class. Okay, so we're going to use this vocabulary. We're going to write a noun or verb to identify how the word conjecture is used in each sentence. So I make a conjecture that your volleyball team will win. So I'm making something about your volleyball team. This is being referred to as something, so this is a noun. Number 5, assuming your sister ate the last cookie is a conjecture. Being referred to something is a conjecture. This is a noun. You conjecture that your town will build a swimming pool. So you do something. You conjecture. You're doing something. This is a verb. Okay. All right, so some more definitions here. So we're going to write the correct word from the list to the right, okay, and we're only going to use it once. So which of these words represents this diagram and its name? So this is some little tiny thing. We call that a point. Okay, so this is a point, and we call it point A. So check that off. Now, this is something that goes on forever in both directions. Okay, so this is called a line. And notice how we name lines, A, B with a line on top of it. This is something that looks like a little square, looks like a little piece of paper, but in reality it goes on forever in all directions. So this goes, and it's called a plane. Okay, now notice this is kind of like a line, this next one, but it doesn't go on forever in either direction. It has 2 endpoints. Something with 2 endpoints is called a segment. Okay. This one has 1 endpoint and goes on forever in one direction. This is called a ray. Now, we have 2 rays that go in opposite directions. So these are called opposite rays. All right, now we're going to draw a line from each item in column A to its description in column B. So here's the figure we're going to use to help us. Plane HGE. So HGE is the bottom here. So this would be the plane containing the points E, F, G. That's the bottom. There we go. Okay, this is line segment BF. Okay, line segment BF. So where is BF? Right here. So it looks like this is the intersection of 2 planes. So it's the intersection of plane ABF, the back plane, and CGF, CGF. So we want this. All right, plane DAE. Plane DAE is the same as plane AEH. So more than one way to name a plane. Line Y is this thing that goes on forever and contains EF here. So the line that goes through points EF. And then point A is the intersection of line segment AB and line Z. So there we go. All right, so complete each postulate with the word line, plane, or point. So postulate 1-1, through any 2 points, there exists exactly 1 line. Postulate 1-2, If two distinct lines intersect, they intersect in exactly one point. Postulate 1-3, if two distinct planes intersect, then they intersect in exactly one line. And postulate 1-4, through any three non-collinear points, there is exactly one plane. Okay, so postulates are items that we accept as truth without having to prove them. And these are very important postulates that we will use throughout the course. All right, so we're going to write P if the statement describes a postulate, or U if it describes an undefined term. So in number 19, a point indicates a location that has no size. So this is just an undefined term. It's not one of those postulates we just described. Okay, number 20, through any 2 points, there exists exactly one line. That's a postulate we just described. 21, a line is represented by a straight path that has no thickness and extends in 2 opposite directions without ends. So that's an undefined term. 22, if 2 distinct planes intersect, then they intersect in exactly one line. Well, that's a postulate. 23, if 2 distinct lines intersect, and they intersect at exactly one point. That's a postulate we just discussed. 24, through any 3 non-collinear points, there is exactly one plane. And that is a postulate we just discussed. All right, so naming segments and rays. So EF and FE, ray EF and ray FE form a line. Are they opposite rays? Explain. So here's a line, and let's just draw it. So here's E, and then here is F. So we have E that goes this direction, EF, and we have FE that goes this direction. So are they opposite rays? I don't know. Let's check this out. So 25, draw and label points EF, then draw EF in one color and FE in another color. Well, I probably should have drawn it in another color, but I didn't do that. So 26, do EF and FE share an endpoint? They do not. Do EF and FE form a line? Yeah, they're on the same line, yes. Are EF and FE opposite rays? Well, no. So these 2 things together mean the third. Explain your answers. Okay, so here's a sample answer. The rays point in opposite directions. But they do not share an endpoint. Okay, let's see if we understand what we're talking about. So each surface of the box at the right represents part of a plane. What are the names of the 2 planes that intersect line BF? So here is BF, and that's right here in the front. BF's right here in the front. Okay, circle the points that are on BF or in one of the 2 planes. All right, so here's A. A is on the plane that contains BF, so that works. BF is on the line. C is on this other plane. D is in the corner, so no. E is on the bottom, so it's on the front plane, yep. F is right here, it's on the line. G is on the side plane. And H is on the back, so no, that does not. 31. Circle another name for plane BFG. BFG, so what other points are on there? BCG, so that works. Underline another name for plane BFE. BFE, so how about ABF? Okay. Now name 2 planes that intersect BF. So here's BF. So we got the front plane, we got the back plane, the top plane, the bottom plane. So we have 4 planes that intersect BF. ABE, ABF, BFE, and AFE. Okay. We also have, going some other ways, BFC, BFG, CBG, and CFG. Okay, those are all variations of pretty much the same thing. All right, so here we go. Use the figure below, draw LM, LN, and MN as dashed segments, and then shade this plane. So LM is across the top, so here's LM. LN is this diagonal here, and MN is this diagonal here. Then shade this plane. Here we go. And then 34. Underline the correct word to complete the sentence. LM, LN, and MN form a triangle because it has 3 sides. Name the plane. So any of the following would work. LMN is obviously what we would give you there. You could also have said MNL. You could have also have said NLM, MLN, LNM, and ML. Anything like that would work. Okay. So underline the correct symbol and explain each sentence. So are A, B, and BA the same ray? So the endpoint of AB is A. The endpoint of BA is B. Okay. Use the line, draw and label points A and B. So here is point A. Here is the point B. Then draw ray AB and ray BA. So here is ray AB and here is ray BA, excuse me. Okay, are AB and BA the same ray? No. Okay, they point in opposite directions. And have different endpoints. Okay, and then here's your words that you should understand by the end of this section, and hopefully you understand it.